Yeah, so I'm actually really happy that I get to talk right after Tim's talk, because a lot of what I'm going to talk about is going to hit on some of the same concepts and principles he brought up. And I know Doug also sort of gave a keynote about MorphoSource yesterday, covering a lot of the conceptual and philosophy side of MorphoSource. So I'm going to try and complement that rather than duplicate that. And because I also have a research background in morphometrics, I sort of wanted to focus on how does MorphoSource as digital repository infrastructure, how does it sort of support and strengthen a pipeline from data production or even data being held by museums or by different researchers to connect that data to analyses. And I'm glad I put 3D, because I will say that pretty much everything I'm going to say could apply to 2D, but it's really specifically about 3D, because 3D is where things really get hairy, where you start to enter a wild west of file formats, and you start to get to things that have very heavy metadata. And actually doing research with 3D, I mean, I don't think I probably need to tell this room, just becomes so much more time intensive and labor intensive. So really, I think modern morphometrics, again, I don't think I'm saying anything controversial here, requires large samples of data. And to answer what we hope will be sort of transformative next generational questions is going to require successively larger and larger samples of data. And as someone who has personally spent time CT scanning, making meshes, landmarking things, it is not using the full extent of our technological potential for every researcher to be duplicating these things. That the power of the scientific questions that we can answer is, like I said, I think this is not a controversial statement, is going to be enhanced when we can bring data together from many different places, potentially created by different teams and different modalities, where all of that data is described, stored, and curated appropriately, that it is possible for a single researcher to contextualize all of the information in other words, out of the sea of data, for any individual researcher to be able to slice what they need and to be able to learn, can I use this without having to manually download 10,000 zips from Zenodo and manually see if the data is appropriate for them. And MorphoSource, as a sort of research-focused digital repository supporting 3D media that represent physical objects, mostly biodiversity specimens, we've put a lot of work into how we have built the site thus far and where we plan to go, specifically to support this data production to analysis pipeline. And so my talk's going to be sort of split up into two parts, where I'm going to talk about the things that MorphoSource does now to support that, and I'll get into some of the nitty-gritty of actually sort of exploring some of the MorphoSource site features. But I'm also going to talk about the future features that we have planned to sort of enhance this pipeline in the future. Oh, yeah, and just by way of a small outline slide, the current features that I will discuss, I'm going to talk a little bit about the site's data model and the metadata, about how they allow for discovery and contextualization of large samples, just some basic site features, the different ways that data can be submitted to the site, including potentially large amounts of data, our REST API for metadata queries, and also how we are currently and are working on building linkages and connections with other infrastructure resources like Specify. So just to, from the top, this is the full sort of set of media types that we support on MorphoSource. Most things on there are meshes, CT image stack, but we do support photogrammetry image stacks, 2D images, and video. I'm not going to go all the way through this, but this is the full list of media modalities that we are capable of supporting. Though I will say X-ray, CT, micro CT, and photogrammetry probably have sort of the highest, we have the highest amount of metadata for those. I think we have sort of more data in those than probably most of the other modalities combined. So data model, and Doug talked about the data model some, so I'll sort of go a little quickly over this and just sort of try and get to my point about how this data model sort of helps researchers to sort of easily determine whether data is appropriate for their use case, to sort of contextualize things with a diversity of levels of curation. So, in MorphoSource, we have a number of these entity and event records. We have, we can sort of like talk about it narratively, that we have an institution record that is associated with a physical object because the institution manages that. The institution also manages a device. We usually call institutions organizations, so you hear me use that term. That devices are used to image objects through a metadata record called an imaging event to create media, which can then be processed via a processing event to create media. And each of these record types has its own metadata profile. And there are many strengths to this model. One is that by having these different records and associating them like this, it allows us to take sort of different dimensional axis slices at the data. It's possible to say, I want to see everything scanned by a particular CT scanner. It's possible to say, I want to see every scan created of a gorilla skeleton because someone may have, scanned the lower leg while someone else scanned the skull. So it allows you to sort of combine things. But it also potentially allows you to say things like, I want to know everything that was scanned in a certain method. Like I want to know everything that was scanned via CT with pixel spacing values between, this resolution and this resolution, because that really matters. I'm studying a really small anatomical element and I need that level of resolution. So that sort of, like I said, it gives us sort of different dimensional axes to sort of slice data by. I think Doug sort of got into this, but the imaging event processing thing, you can sort of stretch that or squish that as sort of for really, really granular deposits where you want to describe everything really explicitly, or really coarse ones where you want to have just the key facts. And of course, in many cases, because of the imaging event, you don't even necessarily need the rawest form of data, which I really recommend people. The rawest form of data people upload is the one that's going to be most reusable, sort of high yield data, that sort of thing. And and so that's sort of data model. Like I said, every one of those records also has sort of its own metadata profile, and wherever possible, we build the metadata from community standards or from trying to pay attention to many different conversations, many different standards. So, but especially for media, I will say MorphoSource is an RDF, a resource description framework repository through the foundation software that powers it, which a repository being RDF is like, it's one of those things that probably doesn't matter to many researchers, but for tech people, it just means that the metadata can be classified in a machine readable way that is sort of a community endorsed standard. These are all sort of examples of either ontologies or controlled vocabularies that we use for either field names. So for instance, using Darwin Core for the names of our fields to describe physical object records, all the way down to probably the most complicated ontology we use right now is for cultural heritage objects, not biological specimens, for describing the material that a cultural heritage object is made of, like clay, or the object type, like an oil lamp. We're now using the Getty Arts and Architecture Thesaurus ontology, which lets us be allows cultural heritage workers to be very detailed about how they describe these things metadata-wise. And we're continually working on, even in this current section, I'm going to keep dipping into things we are doing towards the future. One of the ones we are looking towards is sort of an anatomy ontology. We're using Uberon and other ontology systems like Futrez to do that, but I'll touch more on that a bit later. So we've also been sort of actively involved in many different community groups sort of working on this stuff. So I'm one of the co-chairs of the IIIF 3D technical specification group, trying to incorporate 3D into IIIF, which is a specification for image transport for different computing systems to basically display and communicate images for display. We've been involved, Doug's especially been very involved in the community standard for 3D data preservation. We've got collaborations with the Smithsonian. We are working, Doug is the head of a working group with Audubon Core to try and expand the term set there for 3D media. And yeah, in January 2020, we sort of had a whole meeting about this. It was literal weeks before the pandemic set in. So it was good timing, as it were. We've also done sort of various rounds of sort of stakeholder feedback. And I will say that sort of from a researcher audience, I would love to hear feedback more in the later of the talk when I talk about our future plans. I would love to hear people talk about, wow, that idea sounds garbage. That's not useful at all. Or that would be phenomenally useful. Or it would be useful, but only if you did this thing. Because I feel like that's how we're going to know that it's actually going to be useful by sort of surveying stakeholder groups like you all. Yeah, site features. I'm going to go through this probably pretty quickly, but I did want to sort of show the site a little bit. That's the front page. You don't need an account to browse data, so anybody can browse data. But to download, users must register a user account. The reason for this, and I know Doug talked about this a lot, is that MorphoSource wants to encourage virtuous cycles where researchers want to upload data. And the reason why is by being able to provide museums and researchers with usage tracking, with who is using your material, what impact is it having, to create alternate currencies of impact in addition to just citations. So people do have to make user accounts to download. They also, once they make an account, they apply for contributor status if they want to upload media. So we're pretty much just, we allow pretty much everybody, but it does help us keep track of it. There are two ways to get data into MorphoSource. One is manual data submission that's on the website using the web UI. And so that process uses like a decision tree setup. So it sort of starts the process and it's like, let me ask you a few questions about your data. And if you say that it's a CT scan image stack, it's going to send you down a different route of that decision tree than if you're uploading a mesh. So it's the submission process, because as you saw, there are a ton of records with a lot of metadata. The submission process sort of tries to make it as intuitive as possible by actually interactively guiding the user through the submission process. Though, of course, that in practice means that uploading any individual media can take a few minutes. And so we also I'll give a little bit of context. We relaunched the site in February of 2021. We basically rebuilt the software from the ground up. So there were a few features that we had before that we're only sort of reintroducing, like new, better versions of those features now. And one of them that we just recently released is batch data submission. I should say data submission batch at the top, which allows contributors to submit like a whole bunch of data all at once. The basic process for that is that the user uploads files to an SFTP server. They fill out all the metadata for each file, the physical objects that it represents, what the resolution information is. So like the pixel scaling for CT media. They provide that in an Excel file. You can see an example of it here. It's very wide horizontally in order to allow people to provide. People only have to provide a core set of critical metadata, but they are able to provide a broad diversity. So they provide the metadata here in the Excel spreadsheet. Then they come back to the web interface and upload the Excel spreadsheet. The server finds the files and uploads everything and sort of uploads it in the background. The user comes back in, checks, and the media has been uploaded at a later date. So that's sort of the batch submission. Once you upload media, you end up on a media show page like this, which sort of shows you details about the media at a glance, an interactive preview. You can actually do measurements and landmarks in the browser, which I'll talk a little bit more about that if I have time. Ownership and permission, so licensing metadata. You can get really into the nitty-gritty on that page about the image acquisition and processing. The whole purpose of the site is to give people the ability to, if they want, to maximally sort of curate and describe the image acquisition and processing narrative for media. We mint DOI and ARC identifiers for media, and from that page you can also find things like this is actually a physical object page. So you can see that there are 5 media representing that physical object on the site. Yeah, I think Doug sort of talked about this. So I think I'm going to skip over this, but we do track the usage of what people are using the data for, because that allows us to communicate to museums and uploaders, hey, your stuff is being used this much and for these reasons. Similarly, along with that, when people upload data, they have a lot of control over how the data is accessed. They can just make it totally private. They can make it published with open download, which means anybody can download it. Or they can publish it with restricted download, which means that a user has to specifically request permission. And when they do that, the user says, oh, I want to use this for this. And then the contributor has a dashboard on the site for basically adjudicating these requests. And sometimes they'll go and have emails off-site to sort of discuss specific needs. We have a pretty multi-featured sort of search tool where you can search media records, physical object records, organizations, and projects and teams, which are user-created collections, sort of buckets of media. And all those searches can be faceted and filtered, which means in addition to just keyword searches, you could browse the different media types. Say, I just want to see meshes. I just want to see meshes created via photogrammetry. Oh, I want to see those that are tagged ground sloth. And then you can sort of drill down from general to specific through that in that fashion. Yeah, projects and teams, as I was saying, yeah, media can be grouped by contributors into containers known as projects. So that could be for a paper, it could be for a themed group, it could be for a museum collection. You also can use projects to share access to media with other users. Teams are sort of like mega projects. A team, one of the two main use cases is if you're a lab group and you want 4 people in the lab to all have access to data that's spread across 10 different projects. You could use a team where the team is the lab and then the team has multiple projects. The second use case is for museums. So we want to, we feel that museum collection staff, of the many stakeholders involved in digital representations of specimens, the museum staff are the ones that have the longest term institutional incentive. They're the ones caring about this stuff for decades, for centuries. And so we have a feature called organizational teams, where curators, collection managers, collection staff can basically sign up for a MorphoSource account and say, I am the official representative of my ichthyology collection. And when they do that, it opens up sort of new sort of bonus features, hidden features in the site where that collection staff can then see, oh, so I can see in one place where all of the stuff from my collection that are on MorphoSource are. Even if they're private, even if I wouldn't be able to see them otherwise, I can still sort of see that they exist. They also, yeah, again, I think, yeah, Doug also talked about this, the organizational team managers, they can state like default licensing preferences for museum collections. They can even, at this point now, state, they can click on a setting that says, I want, when media is uploaded that represents specimens from my collection, I want to manage those data eventually. When those data are published, at the very furthest, I would like to have the option to manage these data. The collection staff doesn't have to, but they do get the option. And the user, when they upload that data, they are sort of made very aware of that. They have to agree. It only applies, it doesn't apply retroactively, but if someone uploads media and it says, this ichthyology collection of this media that you are uploading mandates organizational control. So museums are able to sort of have that oversight. Yeah, that's just an example of specifying sort of default permissions things. I think Doug showed this yesterday. All right, so that was sort of site features. Moving in a slightly more technical direction. So we do have a Json format. So that's JavaScript object notation for anyone that isn't familiar with that. JSON, it's just a format that computers can use to exchange data across a number of different purposes. So we are on version 0.1.0 of our API. It's very early days. This is one of these things we used to have a different version on the old site, but we're rolling out a new, better version. And it allows users, it can do a few other things, but principally it allows users to query or search records, the same records that I showed you in the search. It's also, this is one of these things that probably matters more to technical folks. It's documented through a Swagger OpenAPI 3.1 specification, which is just, I don't know if you would say it's best practice, but it is a community endorsed standard for just describing what an API can do, which makes the API much more machine readable. It makes it much easier for someone else who is not Doug or myself or one of our other developers. Someone who knows nothing about this, it makes it much easier for them to build software that then is able to read MorphoSource and is able to do things with MorphoSource data. Yeah, so this is just an example of sort of our media query endpoint. So how you get a single media record through our API, and all of it's because we have it in that open API format. We're able to make nice, pretty documentation pages like this, which users are allowed to provide an API key, which I will mention that a number of times because the API key is a user can use that to basically access private data on MorphoSource through the API. So if maybe the user builds an R script that wants to communicate directly with MorphoSource, they can provide an API key. It's kind of like a password. And that way they could see all the private media they have access to gain access to that with their R script. Normally it would be really horrible practice for me to just put my user API key out there, but I immediately generated a new one after this. So it's just throwaway information. And yeah, and this is sort of what you get, where it's basically just an individual media record with sort of the media type metadata, the modality metadata, that sort of thing. Similarly, yeah, this is the same thing, but instead of querying a single record, this is how you query multiple records. And it really does sort of behave largely identically to that search page. So if you go through it and you can again provide the API key, looks a lot like the one I just showed you. The difference is that it's actually showing you multiple of these. It also, via the API, exposes the faceting. So the same way on the website that you can do the filtering, the browse category by category, the API also makes that available. It sort of enriches the amount of data that one could use to build downstream software tools. Yeah, so future directions. So right now the search, it sort of works on a general keyword search, and we're going to expand that to work on sort of field specific searches. We're also going to give users a lot more control over basically the response they get. What are the vocabulary and the schema that the API response uses. So it can flip from MorphoSource terms to explicitly Darwin core and Audubon core mapped terms. Can you get it in XML instead of JSON? Can you get it in a more explicitly RDF formatting? Again, one of these things that's really important for you know, coders, basically. And one of the things that API allows us to do, and this is one of these things, this is sort of perfectly balanced between things we are currently doing and things we are going to do in the future, are because we always want to have maximal linkages between MorphoSource and other digital biodiversity resources. So for instance, which, yeah, specify, starting with specify 7, you know, if MorphoSource has the media record and specify has a specimen record, you know, as we were talking about, specify you can then send via an IPT, you can aggregate your specimen records in GBIF, or I will admit thus far we have historically worked more closely with iDigBio, which is sort of, it's not only US, but it is a US project. It's sort of the American equivalent of GBIF, but they all speak the same language. So we definitely plan to be working more closely with GBIF in the future. But so if specify is aggregating their specimen records in GBIF or iDigBio, MorphoSource, so currently right now, we pull down, so if someone then uploads media representing that specimen, when they upload this, they can actually search iDigBio for the specimen record, and they can say, oh, that's my specimen, and then they don't have to enter any more information from it, because we know it. We already have it from the aggregator, which means we can keep it updated, we can keep it linked. It also allows us, we only keep I call it like a lightweight specimen record, because MorphoSource is not specified. We are not a specimen collection database. We're a media collection database. We only want as much knowledge about the specimen as it takes to be able to contextualize that media. And so this allows us to sort of have that lightweight record. And having these API-based media metadata endpoints also allows us to sort of close this loop of putting up, right now, an organizational team manager, so a museum collection staff who has a MorphoSource account, can actually pull down JSON or CSV format metadata records of all the media on MorphoSource that represent specimens from their collection, which they could then pull that reference in to specify, so that they would be able to, basically just closing this data loop, making sure everything is linked, everything is connected, so that we can hopefully build larger data sets. And one of the things we would like to be doing actually is also just to start pulling in specimen records directly from collections databases like Specify. So, just skipping the ID5 GBIF, that will always be very important, but having the facility to do it would be helpful. Yeah, and so that's sort of the current stuff. I think I maybe have about 15 minutes left. I'm gonna try and just talk about some of our future plans, and some of these are more directed at data producers, some of them are more directed at data consumers, but also enabling data producers to put more data in directly helps the data consumers, because then there's more data for them to do work, for them to do research with. So first of these, this is sort of a data producer thing. So let's say we have a use case where there is a MorphoSource user that has data, and they have it in a server. They have it in a university-specific server. And they want to make the data available in MorphoSource, but for any number of reasons, maybe they don't really want to then restore that data on the MorphoSource data server, which could really be as simple as, I have 10 million 3D scans and I don't want to upload every single one of them. Or maybe, maybe I have more IT infrastructure than I have, storage funding for it to be funded, stored in a lot of different places. And so one of the things that we are working on right now are remote backed data sets. So these are MorphoSource media records that are metadata only, that then actually point off to a remote server for where the data actually lives, which it's one of those things that's very simple to sort of describe it like that. When you start thinking through it, it very quickly becomes complicated and potentially fragile. But because like some of the basic requirements, the media has to be a URL accessible somewhere, because if we're going to do it this way, if someone wants to download that media, we have to be able to route them back to the original source. And at MorphoSource, we have to be able to check those media. We want to make sure, does it still exist? Is it still the same file that it was originally? But we also need machine readable metadata. So wherever it's stored in that server, we need to be able to somehow get a notion of that metadata in a standardized format. Yeah, and all of that has to be persistent. We have to have a notion that this is going to stay there, because we can't start ingesting these if in 5 years they might disappear. So we have to have sort of a notion of long-term accessibility, which sort of, the way that would work is go to MorphoSource, you give a URL for a media rather than directly uploading it. Our server would sort of go grab the file once along with its metadata. We automatically sort of run files through a processor to see things like, how many points does this mesh have? What's the file size? But we also generate derivative previews, because that's what enables all the media on the site, not all of it, but most media on the site to be interactively previewed in the browsers, because even if the CT scan is 20 gigabytes, we are creating a really tiny sort of derivative asset preview for that. So once we had that, then we would have to, on a regular basis, go back, do fixity checking, make sure it's still there, make sure that it's still the same file. And then we need an automated process for when something goes wrong. There has to be, obviously it'll have to hit a person, but you need as little manual intervention as needs to happen. So when people would want to use that media, they would have to be informed, well, this is remote media. And, sometimes people are downloading 200, 300, possibly more, possibly 1,000 media. So if they need to be informed, well, 26 of your media are in this other place, and you need to go here, but that's, and then routed to the remote file as appropriate. But so that's something we've been working on. And related to this, oh yeah, so yeah, this is helpful. More data in MorphoSource is going to make more larger data sets available for research. So this will help make MorphoSource certainly more sustainable. It represents a lot more community investment. It, however, is obviously it's a fragile solution. At least to start with, it's going to be a bespoke solution, which sort of custom built for this purpose. So I think it's one of these things that will be useful and will be important to many stakeholders, but it probably will take some time to sort of figure out exactly how to. It'll probably go through a number of iterative processes, really. Another related case here is, if you say are an institution who would like to have your own version of MorphoSource. Say, for instance, maybe I have lots of servers, and instead of uploading my things to MorphoSource, can I run the MorphoSource application and then somehow have that be available in your central service? That is something that we really are working on supporting. So on the technical end, the software that runs MorphoSource, we have again, interesting to tech people, not so much to researchers, a Docker container for spinning it up very easily. But what that means is if we have a fake museum here that wants to run on their own servers a version of that, excuse me, even if they want to sort of keep that dark, sort of keep their own data, or if they would want to spin up a cloud version and then have the data from that cloud version communicate back to the central MorphoSource, that is an option that we're working on making available. All right, improvements to the API. Sorry, one sec. Yep, improvements to the API. So everything I showed you right now is for querying metadata. But in order to really connect into sort of larger data resources, in order to enable people to build downstream software tools, people are eventually going to need the ability to download files via the API or to upload files via the API so that someone doesn't have to interact with the website. But this can be a bit tricky for us because MorphoSource and our contributors rely on usage and impact tracking. So we have to sort of thread a needle here that allows people to sort of pull down data through an R script or something, or through a Python script that still lets us do usage tracking, which basically we're looking at sort of greatly expanding how we use the API endpoints and specifically the user API keys, so that someone who wanted to, a data producer, would be able to put together a data bundle, sort of an HTTP put request that would have their authentication usage key, all the metadata they wanted to add in the file binary, so they could push that up to MorphoSource API-wise. Or alternately, someone, again, through an R script, Python script, or through some other downstream tool, could do an API request like that. Include their API key. Maybe they include the usage information, or right now you can actually just fill out your standard usage information on the site, on your profile. As long as you've done that, then you would be able to just download things as long as you sort of provided a short usage statement. All right, this is the one that's really more metrics landmark focused. So right now on the site, so this is our interactive preview for media, and right now users can place landmarks and do, shown here, but you can do 2D linear and angular measurements on landmarks. This is all in the browser. And you can actually export those landmarks in JSON. So it's right there. You can actually then re-import those landmarks into Google Model Viewer. So this is compatible with that. But the one problem with it is you can't directly save or share those landmarks. You can put them in the browser. You can't save them right now. And so I think the obvious solution to that is we want to build a landmark annotation server that stores profiles of landmarks that are associated with MorphoSource media. And we are continually participating in discussions around community standards relating to landmarks, which I feel like it would be accurate to say that it is an active topic for discussion, but I don't think that there is community consensus as of yet. So I think what we're likely to do is to just throw a beta version out there in the world and then try and fix it when someone says, hey, this doesn't match this goal of a standard or something like that, to sort of iteratively improve upon it. Because this is why we haven't built this yet, actually, because we've been in so many conversations and everyone's like, we need community consensus ontologies for landmarks, and whatever discussion you're in, sometimes people are talking about very different things, and we've been like, well, are we in a good place? Is there a community consensus? And I think we're just going to do it. We're just going to do it and see what happens. Which something really nice this will allow is for morphometrics researchers. This will actually would allow users to potentially just upload a morphometrics projects file. So say you have 20 specimens where you measure, you've recorded the landmarks for each specimen and you sort of know what their identities are. This would theoretically enable a user to upload that to the annotation server, and then other users could just directly view the landmarks in the preview on the website. Now, there are a number of challenges to this. I actually think that most of the challenges here are social rather than technical. It's about access. It's about if someone uploads a baboon skull, what users do you allow to then save annotations? How do you make sure that that's quality data? How do you make sure that the chain of authorship is in place? But all those things are more social problems than code problems, which that's the problem. The challenging things are always social. But, yeah. And where we would also like to take this with these landmarks. So yeah, as I was saying, where possible for our metadata, we use data vocabularies. We're starting to use more complex ontologies. Like this is actually the Getty Arts and Architecture ontology I mentioned. And we want to, for media, you can specify, say, anatomical element. We would like to bring the Uberon ontology to that. But where we would really like to go, this is like the ultimate goal, the dream would be able to support landmarks that are placed on media by users, by research projects, through a variety of sources, where each landmark is itself described with an ontology in a way that is machine readable, that other resources can use it, so that when you would have this old world monkey, this colobus skull, and someone say landmarks the glabella, that landmark would have a description, a human readable glabella description, but it would also have a link to the Uberon ontology page for the glabella, which would mean that someone could then search on MorphoSource not just how many scans are skulls, but how many scans have a good glabella. Which, if you're thinking about for fragmentary fossils, say hominin skull fragmentary fossils, you could probably pull up a lot of non-complete skulls for hominins that nonetheless have a glabella that could potentially be of scholarly interest. Yeah, so, and yeah, but so that's sort of the dream, and yeah, hopefully that should be able, you should be able to use that to sort of assemble larger, more comprehensive, higher quality data sets. But of course, yeah, how do you do that? How do you get to that place? And I think it has to involve multiple answers. You've got to approach it from a lot of different directions. Yeah, we already have, people are already filling out an anatomical part field with what the element is of the media. We need to work on our end of mapping those to a more standardized, so like Uberon. We also need to just provide tools for users, say if they're landmarking things in the browser, for them to automatically ID these things and save them. Because there are already people publishing papers where they will describe their methods. Well, I took length measurements from 10 specimens on morphosource.org. Or they're just doing it in the browser and then directly going to publish on it. So we need to have ways to keep that, make that trackable. But we could also be integrating with other tools actually to leverage citizen science and like ontology aggregators. Like there's some tools, Zooniverse / Notes from Nature, that allow scientists to basically create tasks for citizen scientists to classify, here are two images, which of these is more likely to be this organism or something like that. The Futres trait ontology, which sort of overlaps with Uberon, we're talking to both of those groups about sort of creating a data loop where people from MorphoSource could create sort of landmarking tasks with data that would be automatically uploaded to Notes from Nature, would then get aggregated by Futres, which would supply ontology traits, and then we would end up with landmarks in MorphoSource that were well described with trait ontologies and anatomical element ontologies. So, but again, that's like I said, I think it's going to take a number of different pathways to get there. All right, and this is really just sort of my conclusion slide, which is, you know, it is definitely, I think, our belief that sort of enabling production, upload, curation, discovery, and access to larger and larger amounts of data in machine negotiable, which by that I mean machine readable, but where you could also give a researcher a tool that allows them to very quickly gather lots of data, because the human element always has to be part of it. I think we're a long way off from automating away researchers, obviously, but you need tools that enable researcher to negotiate databases better. That doing all of this will enable transformative morphometrics research by allowing those data to be accessed by, connected to other infrastructure, and yeah, downstream researcher-facing tools and analyses on the cloud or locally. And I realize this is like a very heavy flow chart, so I wanted to have one non-monotonous image. And whenever I think of scientific infrastructure, right, I always do think of Jurassic Park. And really, I think the problem of Jurassic Park was not playing God or whatever. It was that they didn't survey their stakeholders until after they built the stupid thing and not before. So that's why I'm saying we're explicitly looking for feedback so that we can avoid this. All right, thank you.
Yeah, well, next, so I guess should we just have questions? It's great if anyone wants to have a question now.
Yeah. When you have the landmarks and what's good, then there it goes.
I think it would be really fascinating idea to do that. Absolutely. It's largely through Doug and Sean and I working through with this applied math working group. We have talked about the possibility of working with neural nets many times, which I think has been a very interesting discussion. I feel like the question that we've always had for doing it for research is to what degree can we access the inferential mechanisms that the neural net is using to make these decisions? Because I feel like, as a biologist, that's sort of what I would be interested in. Well, how do you know that that's there? But also, yeah, just for generating large amounts of data, even being able to throw that in a neural net that can take all the skulls that are very similar in shape and sort of give, as long as you give accurate landmarks, yeah, I think that'll be extremely useful.
Machine learning point of view almost fixed.
I think we would love to do that, or to work with someone who was doing that.
Do you do anything to incentivize data sharing? I mean, can this upload 500 terabytes of your own data without sharing any stars for you? Is that
no, on that last well, so at the moment, so it's there are a lot of different things that go into answering that. So we are supported through, because you can't really talk about that without talking about the money and the storage. We're supported by Duke. We're also supported by various grants, including from NSF. And one of the things that our NSF support includes is basically financial support to monetarily, essentially sponsor certain amounts of uploads. I don't think you could see it, but generally when people apply to be contributors, one of the things we ask is how much data are you uploading? And if it's really high yield data, or if it's a small amount of data, then if it's possible for us to sort of sponsor it for like an individual researcher, we will do it. But say, yeah, if someone comes and says, I have 10 petabytes of data that I am ready to upload now, generally we will reach out to them and say, let's look for funding, or do you have funding? And one of the things we've been able to work, this is like even if it's like the science and then the tech stuff is boring, even more boring than that, Something we've been able to work on with Duke is sort of creating a business model that does allow us to receive funds from grants, so that when someone writes a grant and maybe they get data storage funds, maybe they even write in the grant, I will store these data on MorphoSource, and so I'm going to do X amount of money for that. We are able bureaucratically now to be able to sort of take those funds in to help sustain that data. Yeah, Doug, if you want to expand on that.
Or, you know, well, you have to strong state of that way. And I think most users, if they are interested in actually contributing a lot of data to MorphoSource, they're doing it because they are actually interested in sharing it eventually too.
Right.
But you know, one of the reasons why, I mean, it's actually one of the reasons why we have been emphasizing connecting to museums, because I think in the long run, you know, we trust museums based on their mission for making their collections accessible, to make the media on MorphoSource representing their collections accessible. We trust that to kind of come out over like the career interests of an individual user, and in that sense, we can also start to more through tools put into place things like specific embargo periods on data, like data they upload something, and the museum might have specified like a 5-year embargo period for, you know, data sets that are uploaded. Maybe that user could keep it private or mediate download requests personally for up to 5 years after they've uploaded the data. After that, you can take in.
Yeah, and I also think for individual researchers who are data contributors, in a way, the fact that they can upload things and keep them relatively locked down, we've almost found that paradoxically that almost helps lead people to opening data up, because it's more like if you're anxious about putting data out there fully openly, and then you can put it out where, okay, it starts private, and then I'm going to make it restricted download where people have to ask me for permission. It's been our experience anecdotally that after people do that for a while, they start to see the impact they could get from their media, but they also see that there aren't people trying to scoop their research from them putting material up there. And so putting their toe in the water, sort of people, again, anecdotally, do tend to sort of loosen up and sort of they sort of see the light, so to speak, of data sharing.